I'm Saud, and in this video we'll see three basic 2D transformations. We'll see translation, rotation and scaling. First we'll see translation. So let's say this is my axis and I have a point over here whose coordinate positions are x and y. And let's assume that I want to translate this point to a new position, x dash comma y dash. So this is x, this is y, this will be x dash, and this will be y dash. I obtain the new location x dash comma y dash by adding this distance to x and this distance to the old y. We'll call this distance as tx, and let's say this distance is ty. This is tx. So we translated x comma y to x dash comma y dash by adding tx to x and ty to y. We'll write the equations. Our new x dash is the old x plus the translation factor for x, that is tx, and our new y, that is y dash, is our old y plus the translation factor for y, that is ty. In matrix form it will be something like this. Our matrix for the new coordinates x dash, y dash is equal to the matrix for the old coordinate, that is x and y, plus the matrix with the translation factors tx and ty. So this was translation. We translated x comma y to x dash comma y dash. Next we'll see rotation. Before we see rotation, we'll see a basic concept of trigonometry. Let's say this is a right angle triangle. Let this angle be phi and this angle is 90 degrees. The side opposite to the right angle is the hypotenuse. Let its length be r. Sin phi is given by the side opposite to angle phi, that is this side, divided by the hypotenuse. Let's call the opposite side as O and the hypotenuse is r. And cos phi is given by the side adjacent to angle phi, that is this side. We'll call it A, divided by r, that is the hypotenuse. So O can be written as O is equal to, I'll bring r over here, so O is equal to r sin phi and A is equal to, I'll get r over here, it will be A is equal to r cos phi. Now imagine if this was the axis and this point over here was given by x comma y. So x, that is this distance, is r cos phi from here, and y, that is this distance, which is the same as this distance, is given by y is equal to r sin phi. Now we'll see rotation. Let's say this is our axis and we have a point over here x comma y. Assume it is oriented at an angle of let's say phi from the origin, and the distance is r. Now we'll rotate this point by an angle of theta. So this angle is theta, and let the new coordinates be x dash comma y dash. Now we've seen that x is r cos phi and y is r sin phi. Similarly, x dash will be, the whole angle is theta plus phi, so x dash will be r cos of theta plus phi, and y dash will be r sin theta plus phi. We can eliminate r from both these equations. We'll simplify them. So this will be r. Now cos a plus b is cos a cos b minus sin a sin b. So this will be r cos theta cos phi minus r sin theta sin phi. And over here we'll have y dash is equal to r sin a plus b is sin a cos b plus cos a sin b. So this will be sin theta cos phi plus r cos theta sin phi. Now x is r cos phi, so in place of r cos phi we shall write x. So this will be x and then cos theta, and in place of r sin phi we shall write y. So this will be minus y sin theta. This is our new x dash, and over here we'll have, in place of r cos phi we'll write x. So this will be x sin theta. I'm sorry for the messy handwriting, I'm using a mouse. And in place of r sin phi we'll have y. So this will be plus y cos theta. And this is our new y dash. In matrix form our equations will be x dash y dash is equal to the old xy multiplied by a 2 by 2 matrix. The first element is cos theta, next we'll have sin theta, in the second row we'll have sin theta, and then cos theta. Our x dash is x cos theta minus y sin theta. So x dash is equal to x cos theta minus y sin theta. So over here we'll have a minus sign. And our y dash is equal to x sin theta plus y cos theta. So y dash is x sin theta plus y cos theta. So this was rotation in the anti-clockwise direction. In case you are rotating in the clockwise direction by an angle of theta, then this will change to phi minus theta. It will be the same with this, it will be phi minus theta. And in the matrix you will have a minus sign before sin theta, and you will have a positive sign over here in place of the sin theta in the second row. This was rotation. Next we shall see scaling. Let this be the axis. In scaling we alter the size of the object. So if this is a square, and if you want a square twice this size, something like this, then we'll multiply the x and y coordinate of every single vertex of the square by 2. So if this point is let's say x comma y, then this point over here shall be 2x comma 2y. So in scaling, a new coordinate is the old coordinate multiplied by a scaling factor. Let's say sx in case of x and let's say sy in case of y. So y dash is equal to y into sy. If sx and sy are equal to 1, then the original size of the object is retained. If sx and sy are equal to each other, then it is called uniform scaling, as we have seen over here. If sx and sy are greater than 1, then the object is enlarged. If they are less than 1, then the object is reduced in size. It will go closer to the origin. We can try different combinations of sx and sy. If sx is let's say 1, or if sx is let's say 2, and sy is let's say 1, then we can have the square into a rectangle, something like this. The matrix equation will be something like this: x dash y dash is equal to the old x and y multiplied by a 2 by 2 matrix sx 0 0 and sy. So x dash is x times sx plus y times 0, and y dash will be equal to x times 0 plus y times sy, that is y sy. I hope this video helps you. Thank you very much for listening.